When pulling 600 kcmil THHN conductors through approximately 100 feet of 3-inch PVC conduit, several important factors need to be considered to ensure a safe and successful installation. The materials needed for the project include firstly, a block and tackle pulley with a working load limit of at least 2,000 pounds. Secondly, a high-strength nylon rope with a breaking strength of at least 4,000 pounds is required. Thirdly, a pulling sock is required to protect the cable during the pull. For safety, appropriate safety gear is required, including gloves, long pants, safety glasses, and optionally a groin protector. The step-by-step instructions are as follows. Step 1. Prepare the cable. Insert the pulling sock over the conductors and secure it with cable ties. Step 2. Set up the pulley. Fasten the block and tackle pulley high on the pole, ensuring the rope runs smoothly through the pulley. Step 3. Connect the rope to the cable. Thread the rope through the pulling sock and attach it to the conductors using a ball-line knot. Step 4. Protect your groin. If desired, wear a groin protector to prevent injury in case of a rope break. Step 5. Pull the cable. Have one or more people pull on the rope, keeping it taut. Use a slower and steady pull to avoid damaging the cable. Step 6. Guide the cable. As the cable is pulled, use a stick or hook to guide it into the pipe. Ensure it does not get caught or kinked. Step 7. Complete the pull. Continue pulling until the conductors are fully inside the pipe. Some helpful tips include firstly, use a lubricant, such as dish soap, to reduce friction. Secondly, pull in short bursts and allow the conductors to rest in the pipe. Thirdly, if the pull becomes difficult, stop and reassess the situation. Check for obstacles or damage to the cable. Fourthly, have a second person ready to assist if needed. Block and tackle pullers can be purchased at electrical supply stores, hardware stores, and online retailers such as Amazon and Home Depot. Selecting the right pulley system is crucial for the safe and efficient pulling of electrical conductors, especially in underground service installations. The primary consideration when choosing a pulley is its working load limit, abbreviated WLL. The WLL indicates the maximum weight the pulley is designed to handle safely. It is imperative to select a pulley with a WLL that exceeds the anticipated load of the conductors being pulled. In this scenario, with 600 kcmil THHN conductors, a pulley with a WLL of at least 2,000 pounds is recommended. The safety factor is built into the WLL to account for dynamic loading and potential stress concentrations during the pulling operation. A block and tackle system is preferred because it provides mechanical advantage, reducing the amount of force required to pull the conductors. The number of sheaves, or wheels, in the block and tackle determines the mechanical advantage. For example, a 2-to-1 block and tackle reduces the pulling force by half, while a 4-to-1 block and tackle reduces the pulling force by a quarter. The choice of mechanical advantage depends on the length and complexity of the conduit run, as well as the weight of the conductors. High-strength nylon rope is recommended for pulling electrical conductors due to its durability, flexibility, and resistance to abrasion. The breaking strength of the rope should be at least twice the anticipated load to provide an additional safety margin. In this case, a rope with a breaking strength of at least 4,000 pounds is recommended. When selecting the rope, ensure it is compatible with the pulley system and that it can withstand the environmental conditions of the installation site. Inspect the rope for any signs of wear, damage, or degradation before each use. A pulling sock, also known as a cable grip or wire mesh grip, is an essential tool for protecting the conductors during the pulling operation. The pulling sock is a flexible mesh sleeve that is slipped over the conductors and secured with cable ties. The sock provides a secure and uniform grip on the conductors, preventing them from being damaged or stressed during the pull. Select a pulling sock that is appropriately sized for the diameter of the conductors being pulled. Ensure the pulling sock is in good condition and free from any tears, cuts, or abrasions. Proper personal protective equipment (PPE) is essential for ensuring the safety of personnel during the wire pulling operation. Gloves protect hands from cuts, abrasions, and electrical hazards. Long pants provide protection against scrapes, bruises, and insect bites. Safety glasses protect eyes from dust, debris, and accidental impacts. A groin protector is optional but recommended to protect against injury in case of a rope break or other unforeseen events. Before commencing the wire pulling operation, thoroughly inspect the conduit run for any obstructions, sharp bends, or damage. Ensure the conduit is properly supported and secured to prevent it from moving or collapsing during the pull. Clean the inside of the conduit with a wire brush or swab to remove any debris or contaminants. Lubricate the conductors with a wire pulling lubricant to reduce friction and make the pulling operation easier. Insert the pulling sock over the conductors and secure it with cable ties. Ensure the pulling sock is properly positioned and that it provides a secure grip on the conductors. Fasten the block and tackle pulley high on the pull, ensuring the rope runs smoothly through the pulley. Use appropriate hardware, such as shackles or slings, to secure the pulley to the pole. Ensure the pulley is properly aligned with the conduit run to prevent the rope from rubbing against the sides of the pulley. Thread the rope through the pulling sock and attach it to the conductors using a bowline knot. The bowline knot is a secure and reliable knot that will not slip or loosen under tension. Ensure the knot is properly tied and that it is snug against the pulling sock. If desired, wear a groin protector to protect against injury in case of a rope break or other unforeseen events. Have one or more people pull on the rope, keeping it taut. Use a slow and steady pull to avoid damaging the cable. Avoid jerking or yanking on the rope, as this can cause the conductors to become stressed or damaged. Communicate clearly with the pulling team to ensure a coordinated and controlled pull. As the cable is pulled, use a stick or hook to guide it into the pipe. Ensure it does not get caught or kinked. Avoid using excessive force to push the cable into the pipe, as this can cause damage to the conductors. If the cable becomes stuck or difficult to pull, stop and reassess the situation. Check for obstructions, sharp bends, or damage to the cable. Continue pulling until the conductors are fully inside the pipe. Once the conductors are inside the pipe, remove the pulling sock and inspect the conductors for any damage. Terminate the conductors according to the applicable electrical codes and standards. Using a lubricant such as dish soap can significantly reduce friction and make the pulling operation easier. Apply the lubricant liberally to the conductors and the inside of the conduit. Pulling in short bursts and allowing the conductors to rest in the pipe can help to reduce friction and prevent the conductors from becoming overheated. If the pull becomes difficult, stop and reassess the situation. Check for obstacles or damage to the cable. Do not attempt to force the cable through the conduit, as this can cause damage to the conductors. Having a second person ready to assist can be invaluable in case of unexpected problems or difficulties. The assistant can help to guide the cable, lubricate the conductors, or provide additional pulling power. Proper planning, preparation, and execution are essential for ensuring a safe and successful wire pulling operation. Always follow the applicable electrical codes and standards and consult with a qualified electrician if you have any questions or concerns. When pulling wire, always consider the bend radius of the conductors. The bend radius is the minimum radius to which a conductor can be bent without damaging it. The bend radius for THHN conductors is typically specified in the manufacturer's data sheets and in the National Electrical Code, abbreviated NEC. Exceeding the bend radius can cause the insulation to crack or split, which can lead to electrical shorts or ground faults. When making bends in a conduit, use a conduit bender to ensure that the bends are smooth and uniform. Avoid making sharp or abrupt bends, as these can damage the conductors and make it difficult to pull them through the conduit. When pulling conductors through multiple bends, use a pulling swivel to prevent the conductors from twisting and becoming tangled. The pulling swivel allows the conductors to rotate freely as they are being pulled, reducing the amount of friction and stress on the conductors. Always use a wire pulling lubricant that is specifically designed for electrical conductors. Avoid using petroleum-based lubricants, as these can damage the insulation of the conductors. Apply the lubricant liberally to the conductors and the inside of the conduit. When pulling conductors through long conduit runs, use intermediate pull boxes to reduce the pulling distance. Pull boxes are small enclosures that are installed in the conduit run to provide access to the conductors. The conductors can be pulled in shorter sections, which reduces the amount of friction and stress on the conductors. When pulling conductors through underground conduit, be aware of the potential for water to enter the conduit. Water can damage the conductors and cause electrical shorts or ground faults. Seal the ends of the conduit with duct seal or other waterproof material to prevent water from entering the conduit. When pulling conductors through conduit that is exposed to sunlight, use conductors that are sunlight resistant. Sunlight can degrade the insulation of conductors over time, which can lead to electrical shorts or ground faults. THHN conductors are typically sunlight resistant, but it is important to check the manufacturer's data sheets to be sure. When pulling conductors through conduit that is located in a hazardous location, use conductors that are approved for use in hazardous locations. Hazardous locations are areas where there is a risk of explosion or fire due to the presence of flammable gases, vapors, or dusts. Conductors that are approved for use in hazardous locations are designed to prevent the ignition of these flammable substances. Always follow the manufacturer's instructions when installing and terminating conductors. Improper installation or termination can lead to electrical shorts, ground faults, or other hazards. Use the proper tools and equipment for the job. Do not use makeshift tools or equipment, as these can be dangerous. Always wear appropriate personal protective equipment, including gloves, safety glasses, and a hard hat. Work in a well-lit and ventilated area. Avoid working in confined spaces, as these can be hazardous. If you are not comfortable working with electricity, hire a qualified electrician to do the job. Electricity can be dangerous, and it is important to take all necessary precautions to avoid injury. Remember to consult the National Electrical Code, abbreviated NEC, and local electrical codes for specific requirements and regulations related to wire pulling and electrical installations. Following these codes ensures safety and compliance.